How do you do? My name is Bob Jensen, and I've been asked to tell you people something about the history of radio, both in the line of broadcasting and in the line of the receiving equipment that has been used. I feel that I'm more or less qualified to speak on this subject because I've been in the radio business all my life. I retired in 1975 from NBC after spending 38 years with NBC, and prior to that I had about 20 years in college broadcasting and also commercial broadcasting. My father was a pioneer in radio. He was demonstrating wireless at the Nebraska State Fair in 1906. And the equipment that he used is quite a bit different than what we are using and carrying around the joggers wear every morning. We notice the people that have headsets on listening to the radio. And if we could have done that in 1910 or 1915, we would have really thought we had a miracle. But it's sort of interesting to look back and see what these pioneers had to go through in order to arrive at what we have today. And what we have today, of course, is nothing what we're going to have 25 or 50 years from now. And it's really hard to predict where the electronics business is going to go. I think that it can be verified that in the last 50 years we've had the greatest technological advance. That is, 50 years would be compared to the advancement over the last 5,000 years. And in the next maybe 20 years, we'll probably double what we've done in the last 50 years. Okay, referring back to my dad's transmitter and receiver in 1906, he had a spark transmitter, and he used a spark coil similar to the Ford coil that we have here that was used by experimenters in the 1915s and early days. And he would transmit a signal from one side of the room to the other. And the receiver was a glass tube in which were nickel and iron filings. And there were elements in this tube. And as a radio signal would come through, the filings would cohere, as they called it, and change the resistance of the circuit and operate a relay and ring a bell, so that when you pushed a button on one side of the room and sent a signal and the bell rang on the other side of the room, you had actually been broadcasting by radio. In those days they called it wireless. And that receiver was known as a coherer. The many different experimenters used different types of devices to change the radio waves into audio waves. And there were a thing called a carborundum detector and sulfuric acid detectors and many other various forms, when finally the thing that became most used in the mid 1900s, around 1915 and up till 1920 and even up as far as 1925, was a crystal, and a crystal detector. Now this is a commercially built crystal set, and in here is a little glob of lead ore, which we used to call galena. And this little piece of galena could be purchased at the local dime store for between 15 cents and maybe 25 cents if you wanted to get a real big piece of galena. And you would wind a coil and tune the coil to the frequency of a broadcast station that was near you, and using headphones and a long wire antenna. Usually you had to have 100 feet of wire outside, and this would be connected to a water pipe ground. And then you would sit down on a quiet evening and turn this tap, which would turn in more or less number of turns of wire. And then you would start to fiddle around with this little wire, which was called a cat whisker, and find a place on the galena crystal where you could hear audio. Now, we have a very simple device today, which is known as a diode. That's exactly what this crystal detector was. It was a diode. And if you were to replace this crystal detector with one of today's modern diodes, it would pick up a radio signal and you wouldn't have to look around for a place with a crystal. So that's and the modern receivers have lots of diodes in them, as well as transistors, of course. Now, the early experimenters didn't have too much to listen to, so they tried to transmit, and this is an early transmitter. This was built in about 1915, that era. This is a coil, and it made a spark across here, and you hooked an antenna onto it like you did the other, and then there was a transfer switch here. You would transmit with this switch in the one position and throw the switch over to receive in the other. And this part over here is the receiver. It consists of a coil of wire with two sliders on it. This is a fixed condenser, and then here again is the crystal detector. Now this little buzzer was used to set up sort of a signal that you could use to locate a good spot on the crystal. It was sort of an early signal generator, you might say. So with a device like this, you could, in real good luck, you could talk about 5 miles. And my cousin and I used to have a transmitter set up, but we used the Ford coil. This was a coil out of this says Ford right on here, if you can get into it. This was out of a Model T Ford. The Model T Ford, for you car buffs, know that the Ford had 4 of these coils, and they were used to operate the spark plugs, and it made a spark. Now I can put a battery on this and make a small spark here. If you can get real close on this, right at this point here, we should be able to make a spark. You can see that little spark there. Now, when they used a transmitter on shipboard, they used much more powerful devices. They used rotary spark gaps, which were would put out 1,000 watts and even 5,000 or 10,000 watts. Then they created a fluid arc with alcohol in a chamber, and that arc kept going all the time. And they later tried to modulate that by putting a microphone in series with the ground lead of a transmitter, and the first voice transmissions were done by modulating an arc transmitter. Now, the progression went on. In about 1970, DeForest invented the triode. Prior to that, a gentleman by the name of Fleming in Britain had developed called the Fleming valve, which was simply a rectifier and a diode, but DeForest came along and put a grid in the tube which gave you control of it. Now, the use of the triode gave amplification possible, but it wasn't until Armstrong invented the regenerative receiver that the capabilities of a single tube were really realized. And I think that Armstrong should be given almost as much credit as DeForest, because he made the use of the tube possible by amplifying, and the device was used in a regenerative circuit. Now, various receivers came out. This is the first commercial set that was put out it was built by Westinghouse and sold by Radio Corporation of America. This is the type RA tuner. It has 3 controls on it: the tuner, and the tickler, and the vernier. And then over in this case are 3 vacuum tubes. The vacuum tube that became the most popular in about 1920 was the 201A, and this has Well, let's see, there ought to be some way to get this out of here. This is a 201A, and it was a development that was made after the use during the Navy of the VT-1 that was developed during World War I by the Navy. And the 201A became a very popular tube, but it required 6 volts of filament, and it took about 1/4 of an ampere on the filaments. And so it required a storage battery and B batteries to operate it. So to avoid that, they came out with several other tubes that used lower power. Now, also this has 3 tubes in it. The first one is the detector, and then you had 2 stages of amplification. If you were close to a local station, you could hear on headphones with just the detector. But if you wanted it louder, you put the plug in the next plug here, which says first stage and then second stage, and then these controls control the voltage on the filament. That was the only volume control that there was. You people who know about electronics know that we don't control the volume of a vacuum tube amplifier by changing the filament voltage anymore, but that was the way it was done in the very first. Then they came out with a smaller tube, a 199, which used much less filament current, but still, of course, had to have plate voltage, but it would operate off of dry cells. Then there were several other tubes, like the WD-12, which I believe had a filament voltage of 1.5 volts, and then the WD-11, which also had low filament consumption. And in those days, that was a problem because you had to, before everybody had a battery charger, you had to take your storage battery down to the local garage and have it charged. And most people had 2 storage batteries. They had one that they would use, and then they had the other one that they would be down at the garage being charged. So that was a weekly chore for somebody to take the battery down and get it charged so you could run the radio the next week. Then the B batteries, for the plate voltage, this little radio here is a Crosley, and it has 3 tubes in it, and it's a regenerative receiver, and it's a regenerative in 2 stages of audio. And these transformers here were the audio transformers, and when we built our own sets, of course, we were very careful to get the right kind of an audio transformer. And each set also used a C battery. This is a C battery here. That was used for bias. And these batteries, incidentally, are just a little outdated. They have a date of them, May 1926. So I think they're probably a little bit dead. But that was the kind of batteries that was used. Now this is a commercially built set. That was a portable set. It folded up and had a handle on it, and it could be taken out with headphones again. Then a lot of people built their own radios. Now here is a homemade set. They wound the coils themselves, and all this is all wired and soldered. Some of these solder joints aren't the best, but I'm sure it worked. Now this metal, this copper here, was put inside because on some of these early radios, when they would go into oscillation, if you would bring your hand up close to the set, it would change the tuning and change the oscillation. So by putting this copper screen in here, that helped avoid that problem. Okay. The ordinary type headset, there were many different varieties. This happens to be a Cannonball Dixie. This one is. One of the popular brands was the Brandeis, B-R-A-N-D-E-S, and a good pair of headphones would cost about $7.50. I remember saving $7.50, and I got a pair of Stromberg Carlson. That was a real great headphone, and they had 2,000 ohms. That was the big deal. Nobody knew why you wanted to have 2,000 ohms impedance, but that was a lot better than the 1,000 ohms. Then the Baldwin headphone came out. It was a little different principle. It had a moving coil in it and a moving diaphragm, and it was a different construction than the other type headset, and it was actually louder. It had a permanent magnet in here, and the vibrations caused this little diaphragm to move back and forth, and that was attached to this diaphragm here. And it was so loud that you could put this headphone in a bowl and put it on the dining room table, and the whole family could sit around the table and listen to the radio. Then also somebody got the ingenious idea that if you just took this cap off and made a mounting with some threads on it here, that you could fasten it on to the phonograph pickup, take the phonograph pickup off your mechanically operated phonograph and screw this on, and then hook the device onto the phonograph so that you use the phonograph speaker as a horn, and so then everybody sat around the phonograph and listened to the radio. This receiver here, going back a little ways, this dates back to about 1920. This particular receiver was owned by Mr. Kiroff, who started radio station KHJ. Now, he was also an amateur, a radio amateur, and but this is a piece of commercial gear. This is built by Kennedy, and this probably cost in the neighborhood of maybe $250 or $300 back in those days. Now, not too many people could afford it. To look at this device, you'd think that it was a very, very complicated radio and had probably 25 tubes. But if you look into the top of it, you'll see that it has only one tube. And this tube was operated as a regenerative receiver, and it had many different layers of coils that you could switch in by turning these different taps down here, so that it was possible to tune the entire, not only the entire broadcast band, but also the shortwave bands and the long-wave radio. In the early days, it was very popular to listen to the Arlington time signals coming from station NAA in Arlington, and those were on very low frequencies, so you had to use a lot of turns of coil to receive that signal. Now then, let's go from the headphone to a different type of loudspeaker. Let me reach over here and get this. This was the next type of loudspeaker, which was known as the cone speaker. Now, it used the same device that was in the Baldwin headset. It used a permanent magnet and a vibrating device here, and it was a high impedance device that worked right in the plate circuit, and that this moved, and it operated the diaphragm here, and it didn't require any battery voltage to operate the loudspeaker. This was a fairly good speaker and was built into consoles and used for quite some time. Then the next speaker that came out was the dynamic. Now, Magnavox built a dynamic loudspeaker in about 1911, and they're the first ones to build dynamic speakers. This is a horn speaker, but it's actually a dynamic movement in which there is a moving coil which moves in an electromagnetic field. In other words, voltage actually is placed on a coil inside of the speaker, and it gives it much more power. Then our modern electromagnetic loudspeakers developed from this, and finally they got away from the electromagnetic part entirely, so now we use permanent magnet speakers. This is another, this was a Crosley. This came out about 1926. This was they called this a Dynacone loudspeaker. It sold for $22.50, the sign says here. And but you could tell the difference. The dynamic speaker had 4 wires on it, but a regular magnetic speaker had only 2 wires. So that was the way you could tell whether it was a dynamic or not. This has 4 wires, so it's a dynamic speaker. Okay, the biggest problem was the problem of batteries. I mentioned that you had to take your storage battery down to get it charged. Finally, people got Tungar battery chargers, and they would charge their own batteries, but they would still have to buy new B batteries. Now, the receiver would require from 90 volts to 135, even as much as 180 volts of B batteries, and that became quite an expensive item. So they started experimenting with heavy filament tubes. Now, the first heavy filament tube that came out was the 226. It was a 2.5 volt filament, but it had a thoriated filament, and the problem was that if you put alternating current on those real thin filaments that were used for the battery sets, that the filament would vibrate due to the 60 cycle AC and make hum in your receiver. So by using a heavy filament and center tapping it, they got rid of some of that noise. Then from that they graduated to the heater type tube, which had a heater inside of a column, and that was the 227 was the first heater type tube. This is an RCA 227. If you can notice the construction here, I don't know if you can get in on this or not, but you'll notice that there is a white tubular device down inside, and then inside of that is a thin wire that heated this up, and this became hot and emitted the electrons. Okay, so that took care of the filament problem, and now then we had to get rid of the problem of having batteries. Now this set, this is a freshman masterpiece. Incidentally, the dial here is calibrated in meters and not in kilocycles like our radios are today. 500 meters was about 500 kilocycles, and the high frequency end of the band was a lower reading in meters, but it would be higher in kilocycles. Well, now this radio here has wires that was designed to hook the batteries onto, but as I say, they tried to get rid of the batteries, so then came the thing called the B eliminator. Now this is a power supply. It's called a freshman AC power supply, but it was commonly known as a B eliminator, and it would make high voltage with a rectifier, usually an 80 type tube, which was a full wave rectifier. And this is quite an antique tube, this one that's in here. This is a real old 80, and it made a full wave DC voltage. We were talking about going to all alternating current. Well, the next step then was to combine the power supply and include it in the set. And this 1929 Philco here, 1929 model Philco, I think it's a Model 30, was about the first table model that came out. There were a lot of floor models that came out ahead of this, but this is the famous one that you see in all sorts of pictures. Now, there were many different types of vacuum tubes that came out and different circuits, and to go into detail in all the various circuits would be impossible with what we're doing here today.